Okay, we're answering number 16 on page 570. The question is, a conical paper cup with radius 5 centimeters and height 15 centimeters is leaking water at a rate of 2 centimeters cubed per minute. At what rate is the water level decreasing when the water is 3 centimeters deep? So as you can see, we have our drawing of our cone here, which shows the height, the radius, and that h is 3 centimeters. The question tells us that it's leaking water at 2 centimeters cubed per minute. Therefore, the change in volume with respect to time is -2. The question asks us to find the change in height with respect to time at 3 centimeters. So we have our standard cone volume equation right here, but there are two variables in it. So we're going to get r in terms of h so we can differentiate it better. As you can see, using similar triangles, 5 over 15 is equal to r over h, which is 3. So therefore, r would equal 5h over 15, or h over 3. We go to plug that back in to our volume equation so that we have it all in terms of h. So, plug it in for r, and from there it's just expanding until you finally get pi h cubed over 27, or pi over 27 h cubed, which is easier when you differentiate it. So now, to differentiate that equation with respect to time, you have dv over dt equals pi over 27, because it's constant, times 3, which is the 3 from the h, times h squared, times dh over dt, which you really need to include, and that is also what we're solving for. So we know that dv over dt equals -2, so we plug that in. And then on this side, we've just brought down the 27, so that's under everything, and plugged in 3 for h, because that is what h equals when we're differentiating. So you just expand it further. You bring the 27 over here to get -54, and then you expand all the 3's to get pi 27 dh over dt. Bringing this over to this side, you see that dh over dt equals -54 over pi 27. And when you simplify it, dh over dt equals -2 over pi centimeters per minute, which is the rate at which the height of the water is decreasing.